Hello everyone, welcome to the class. Just give me one moment. I would just check if I'm online and we would begin the class. Alright, welcome back everyone. So in today's class, again, we'll be continuing from wherever we left in your first unit, right? We actually began with the motion in a straight line. Sorry, this is your unit 2, motion in a straight line, right? This is basically kinematics. So last few classes we would have seen what is distance, what is the difference between distance and displacement, and what is difference between speed and velocity. That's what we would have seen in the last class. So in today's class we would basically be seeing what do you mean by acceleration, what are the types of acceleration, and we'll just try to find some kinematic equations, right? We would try to derive few of them at least. All right, that's the target for today's class. On that note, let's begin. My name is Mohana. I'm a physics educator at Unacademy. So if you're taking your class 11 or 12 physics, I'll be teaching you, and this is my Telegram link. So here any class update, right, would usually be shared in this Telegram channel, so you can check out the channel for the same. At the same time, this is Unacademy ICSE and ISC board general channel, right? So you can actually follow here as well. Okay, so and then, right, you can try following us in both the channels. So there are, like, how we have these free classes in how we have classes on the Unacademy YouTube channel. We also have absolutely free classes on the Unacademy platform also. So those details on when and how, which are the days we are going to have the classes, this is actually shared in the Telegram group. You can go check out. All right, so these free classes you can study from any of your favorite educators, and you can engage with these educators via pool, and also since these are again live classes, any doubts you have, you can get them cleared as well. So there is a link in the description, so you can click on that link for class 11. It will take you to the Unacademy platform, and you can see what are the you can actually enroll for the upcoming classes. So these classes are absolutely free, or you can also use my code MTIS10 to enroll for the same. Now, what are the free classes? So we actually had one class or two classes of laws of motion. So this month, how the courses are planned is, for class 11 we would basically be taking we'll continue with your unit 1 and unit 2 in the YouTube platform, right? Simultaneously your unit 3 is covered, that is dynamics is actually covered in the Unacademy platform. So 2 classes of dynamics is sort of over, but don't worry, we will do a recap. You can go see we actually started covering laws of motion. So you can go see the previous 2 recordings. Otherwise, in the upcoming class, again, we have a class on 10th June. If you have any doubts, you can ask me and we can do a quick recap, and then we can also continue with the class. Now, 13th June, again, we have a class at 4 p.m. Now, this class will be what are the basic mathematics required for physics. All right, so we would be doing this class on 13th June. Then on 20th June we will learn about, in this class on the YouTube channel, basically we'll learn about what is in motion in a plane. We will learn what is a vector, right, and what are the types of vectors. Now in this class on the platform we will learn what are the practical applications of vectors, right? So you can enroll for these classes. Just click on the link below in the description for class 11. You can go to the class or whichever class you want to take. If you want to take all 3, you're more than welcome to take them. So these classes, whenever we don't have classes on the YouTube channel, we will be having classes on the Unacademy platform. All right, it will be around 4 p.m. So you can just register. You can just say enroll. Okay, and you can take these classes, and when the notification, and also you can say notify me. Basically there will be an app called button as notify me. If you inform it before the class, you will be notified. All right, now we have an upcoming plus batch. So what are the advantages of taking a plus subscription is that you can learn from the comfort of your home, right? And you will have unlimited access to all courses. What do we mean by courses is that when you take a plus subscription for class 11, you will basically get physics, chemistry, math and biology. 4 subjects will be covered in a course. So you're getting a course in total, right? All of the educators on the platform are really good, so you'll be learning from the top educators. Now, every fourth class in your every fourth session is basically, it will be a doubt clearing session. Okay, so if a class starts today, the 4th class from today will be a doubt clearing session. Whatever concepts you learned in the last 3 classes, if you have any doubts, you can actually get your doubts clarified through this. Now, in case if any of the classes you cannot attend the live class, then you can watch the recordings, and if you still have whatever doubts you have, you can ask the same in these doubt clearing sessions. Okay, then in the plus classes, we will cover your entire syllabus, and there will be every other week you will have a live test series as well. Okay, now these live test series will you can, after this, if you take any concepts you're learning, right, any live test you're taking, after the test there'll be an analysis session. So you can you can actually get your doubt cleared in case you got any answer wrong, or you can actually ask your educators in case if you want to know how to solve a question in a much better way or a faster way, you can ask the same as well. So we are coming up with new batches, so do check out. So the new batch, so before I give you the new batch information, so normally if you take any course, right, if let's say if you're taking a course for 1 year, right, then the price per month how much you're paying goes down. So if you're taking the course for 2 years, that is this price over here, right, rather than taking for few months, price per 2 years over here comes down to 1,200, right, some 1,198 over here. So you can use my code MTIS10, and if you use my code, you will get a 10% discount on the same. So you're just getting the course for 1,078 rupees. Now, there is a plus batch starting from tomorrow onwards, but for physics, we will have class on 9th June onwards. The mode of delivery for this course is going to be English. So in this course, we will be covering your math, physics, chemistry and biology. All right. All the 4 subjects will be covered, and for physics we will be meeting every Tuesday, Thursday, Saturday between 5:15 to 6:15. The class is starting only from tomorrow, right? So you can actually take this if you're planning to take a subscription. This is the right time to take, right? And Akshay, good evening, Akshay. And now one of the offers we have right now is, in case you take for class 11 subscription, you can just pay this amount for 1 year. You don't have to pay the amount for 2 years. You can just pay the amount for 1 year, and you're getting class 12 subscription absolutely free. Alright, and you can use my code on top of whatever you're getting, right, to access this offer, and to get a 10% discount, you can use my code MTIS10. Okay, so batches are starting only from tomorrow, so do register if in case you haven't. All right, and with this note, let's move to the channel. Okay, all of you have joined in, so let's begin with our concepts. So here we started with motion in a straight line, right? I want to quickly go through, if any of you have joined new and if you missed the previous 2 classes, so I'm going to quickly give you a brief intro. All right, so the ones like if you have been already following, right, so I'll just quickly go through so you know what we have done. Okay, so we started with what is mechanics, because motion, when we're talking about motion in a straight line or motion in a plane, we are talking about this particular branch in physics, which is mechanics, that deals with the condition, right, of rest or motion of a material object around us. Okay, now this mechanics has 3 sub branches. One is statics, kinematics, dynamics. Static comes into place whenever you're dealing with an object at rest. That's when you get static comes into picture. Okay, now now if you take an object, right, if you deal with object, the study of this motion of object, right, without considering what was the cause for that object, then it is kinematics. That is your unit 2. Whatever we are learning over here is that we are just focusing on of an object that's in motion. Here time becomes extremely essential. Your dynamics, that this is the unit that we are covering in the class on the Unacademy platform, right, that comes into picture. Now if an object is in motion, now if you take the consideration like what is the cause for this motion, then dynamics comes into picture. All right, now this brings us to the concept of what is rest and what is motion. So normally when we're talking about rest and motion, we talk with the frame of reference, with whose frame of reference. Okay, now let's say you are standing on a platform and a train is moving. For you, you're at rest, right? And the train is actually moving. For a person sitting inside a train, okay, for them, they are at rest, okay, and everything around them. If you're in a vehicle and if you just observe, okay, you're at rest. For you, you'll feel you're at rest, but everything around you is in motion. Okay, so rest is an object is said to be at rest if it does not change its position with respect to its surrounding with passage of time. Okay, so we always talk from a reference frame. All right, next, motion is an object is said to be in motion if it changes its position with respect to its surrounding with the passage of time. So rest and motion both are relative terms. Okay, now then we came up with the concept of point mass. Very simple concept. Okay, if you have an object, okay, and let's say that object is traveling a particular distance. Let's say the earth is going around the sun. Okay, now the size of the object is very small when compared to the distance it is covered, right? Now this case where the size of the object is very small when compared to the distance it is covered, then we say that particular object as a point mass, or we call it as a point object. Okay, next comes the concept of motion in 1, 2 and 3 dimensions, right? When do we say an object is going in 1 dimension, right? The motion of an object is said to be on 1 dimension. If let's take 3 coordinate axes, x, y and z. Let's take 3 coordinate axes, x, y. Let me use a different color pen. All right, let's take 3 coordinate axes, right? Let's take x, y and let's say this is z. Okay, now if you can just use any one of the coordinate axes to represent the motion of an object, then we say the object is in 1 dimension. Let's say a car is going in a straight line. That's motion in 1 dimension. Now, if you use 2 of these coordinates, right, to explain the motion of an object, then we say the object is 2 dimension. Okay. For example, let's say there is an insect going zigzag. Then x, y, 2 coordinate axis comes into picture. Then what we have is basically a plane. Right? That's a plane. Right, coming into picture. A car going in a circle, right? That is 2 coordinate axes are required for it. Then motion in a plane comes into picture. Now, if you take all 3 coordinate axes, okay, to specify the motion of an object, then it is called 3-dimensional. What is in 3 dimension? Very simple. Let's say an insect is going zigzag. It is in 2 dimension. Right? Suddenly it starts flying. Right? What happens? Now, it was going zigzag on the plane, right? It was basically going zigzag on the plane surface, right? This is where you got x and y. But suddenly when it started flying, there is another component that got added to it. That is the height. Now 3 components got added. Now there's another component that you have to take into consideration, that is height, right? That's a motion of an object in 3 dimension. So basically a plane, right? A plane that is taken off, right? That is going birds in motion, your kites, right? Kite, that is your flying, right? All of these are basically object in the motion of an object in 3-dimensional. And Akshay, I'm sorry, I'm just seeing your message. Good evening, Akshay. All right, and on this part, we are coming to the first thing that we learned, right? We covered the concept of distance, right? Very simple. We did it with a very simple example, right? Most of us, let's say this is our home and let's say this is our school. Okay. So let's say you're in school. From school, where do? We don't want to go to home directly. So we want to go to an eatery or a bakery, right? From bakery, let's say you're going to your friend's house. Okay. From there, you're coming back home. Okay. Now, the length of the actual path traversed by a body between its initial and final position is basically called as distance. Or the other name we use is basically path length. Okay, so you started at school, you went to home. Home to school, that is also right, Akshay. You can say from home you went to your friend's house to bakery and then to school. That's basically the complete distance that you've covered. Okay, that's basically your distance. All right. Now, this particular distance, it's a scalar quantity. Okay, distance covered can only be positive or zero. We have done this in previous classes. Okay, so I'm just going to quickly go on. If you have any doubts, you can ask me. All right. Now, this is basically the concept of distance. Now, what will be displacement? Now, from school, if you're directly going home, you're not taking all this turn. From school, you're directly going home. Then we can say this is displacement. So displacement takes into picture your initial and final position. It doesn't talk about the complete path travel. So Akshay, correct, that is right. That is the shortest, displacement is your shortest possible distance. Alright, that is correct. So here the next one is displacement. So displacement of an object is the change in its position of an object in a fixed direction. Okay, so it's a vector quantity, because last distance we did not talk about, it was a scalar quantity, but this direction comes into picture, right? From home to school, you are going, in which direction are you going, right? What is the shortest distance over there, right? That will be the just path length that is traveled, okay? That is your displacement. And in which direction did you go, north, south, west, that comes into picture, okay? That is probably displacement. Next, displacement can be positive, negative or zero. Right, we have seen all the cases. Example case for a zero displacement is, we saw home to school. Let's say you're going from home to school, right? And then you're coming back. So your initial place is home, your final place is also home. What is the displacement? Zero. Because displacement takes into initial and final distance into account. Okay, that's right, Akshay, it becomes zero. So this is displacement. Alright, next. From there we learnt what is the concept of speed. Speed is very simple. The rate of change of position of an object with time in any direction is called its speed, right? So normally it is a scalar quantity. Okay, why? Because here we are taking into consideration of path length. Okay, we are not worried about, for example, from your home to friend's house to a bakery, right, to school. Okay, what is the distance traveled? What is your path length with time? How much distance upon time? That's right, Akshay. So when you're talking about speed, you're talking about what is the actual distance you covered. Let's say you covered 2 meters, right? Sorry, 2 kilometers. 2 kilometers with how long? Let's say you took around 10 minutes. So 20 minutes. Okay, now that's the speed we are talking about. Alright, so speed is nothing but distance traveled upon time taken. Now, we have covered this in the last class. That is why I am not explaining these points. If you have any doubts, you can ask me. Alright. Now, distance covered will always be positive or zero. So, the speed can also, because distance traveled can only be positive or zero, speed can also only be positive or zero. But it can never be negative. Okay. Now, it's a speed as a scalar quantity. Okay. Now, the SI unit, as Akshay has said, that is right, Akshay. The SI unit of speed will be meter per second. And the dimensional analysis, if you're taking for dimension, what is the dimension of speed? Dimension formula. Mass is not there, so m0, length is 1, right? 1, and t time is time inverse, right? T inverse 1. That's the dimension formula of speed. Okay. Now, similar to speed, we also have velocity. Now, the rate of change of position of an object with time in a given direction is called velocity. Now, when we're talking about velocity, displacement comes into picture. Okay. Now, it's a vector quantity. All right. And velocity, you can always give velocity as displacement by time. Since displacement can be negative or positive and zero, because displacement can take all of these values, velocity can also be positive, negative or zero. Okay, and displacement by time is basically velocity. Again, what is the SI unit? SI unit of velocity is basically meter second inverse 1, that is right. And Akshay has also given the dimension formula, right? Mass is 0, length is 1, time is inverse 1. That's the dimension formula. So this is about velocity. Right? I'm just quickly covering. If you have any doubts, let me know. We have done 2 classes on these, so that's why I'm going fast. Alright. Now there are different types of velocities as well, right? And different types of speed as well. What are the differences, right? Can you name few of the differences? Different types of speed and velocity. What are the different types of speeds and velocities? Let's start. Number 1, uniform speed, right? if an object is moving with uniform speed means, right, it is covering, okay, from home to friend's house to bakery to school, right? Let's say from here to here you're covering 5 meters, right? Let's say 15 meters in 10 minutes. Again from here 15 meters in 10 minutes. This is again 15 meters in 10 minutes. So here what happens? If you are moving, right? The object is covering equal distance in equal intervals of time. However small the interval is, right? If I divide it even further, these 15 meters by 10 meters, right? If I even make it further small, then each of this division, what is the speed that has to be seen? Okay, now yes, Akshay, one is uniform speed, the next is yes, non-uniform or variable speed. That is right. What is non-uniform or variable speed? Let's say for the first 10 minutes you covered 25 meters, then you covered 10 meters, then you just covered 5 meters. Now what happens? The distance traveled with time is different, right? So this is basically an example, okay, of if an object is covering unequal distance in equal interval of time. That is basically a variable speed. Alright, unequal distance at equal intervals of time. That's right, Akshay. Next is average speed. Alright, next is average speed. Very simple. Okay, average speed is from your home to the school. What is the distance traveled? The total average speed will be total distance traveled by total time taken. That is basically your average speed, right? Next is instantaneous speed. Instantaneous speed is in this entire process, okay, at any given particular instant of time, okay. If you want to see what is the speed, let's say when you went from your bakery to school, right? You want to know what is your speed at this particular instant in time, okay? What is that speed for one particular given instant in time, right? That is basically your instantaneous speed, right? Instantaneous speed, we always give it as instantaneous speed. This is V, right? We always give this V as, right, the amount, okay, the entire, let's say the entire distance covered is X, right? Let's say the entire distance covered is X. Like the small distance, what is the speed over here? This can be given as delta X, okay? The entire time taken is T, total time taken is T. For the small distance to cover, what was the time taken? That will be delta T. So speed will be, in this case, instantaneous speed will be, right, delta X by delta T, right? So this is as time is going towards 0, right? You can give it as limit delta T going towards 0, delta X by delta T. This quantity, right, this quantity is nothing but dx by dt. So dx by dt is nothing but your first derivative of distance, x with respect to time. Okay, an example. Can any of you think of an example of instantaneous speed? Okay, example of instantaneous speed. Alright, till then the same variable, you have uniform velocity, right? In this case the object is covering, in this case the object is moving with a uniform velocity, means it's covering equal displacement with equal intervals of time. Okay, variable velocity means unequal displacements at unequal intervals of time. Okay, the object is covering alright, so variable velocity, when you're actually talking about variable velocity, since this becomes a vector quantity, two things can happen. Okay, two things can basically happen here. The object can change its what to say, it can change its speed, right? Variable velocity is said to be when a body is said to be moving with a variable velocity, right? If its speed changes, right, or its direction changes, then we can say, or if both of them changes, or if both of them changes, because velocity is a vector quantity. Now when we are talking about variable velocity, not just its not just the speed or the distance we are talking about changes. Here you can take about the direction change as well. Okay, that is basically a variable velocity. Average velocity will be, this is very simple, average velocity will be total displacement by total time. If you're going straight from home to school, okay, going straight from home to school, no pitch stop in between. So what we can do, you're not going to your friend's place, bakery and all, you're just going from home to school. Then you can say, this is the total displacement. What is, how long did you take? Let's say you took, you went around 200 meters, right? And the time taken is basically in terms of minutes is, let's say you took around 5 minutes, convert it into seconds, right? So this will be your total displacement. Now, this will be your average velocity. Now instantaneous velocity, similar to that, you also have instantaneous velocity. In this case, what happened? At a particular instant of time, you want to find out what is the velocity, right? Then it becomes instantaneous velocity, right? Instantaneous velocity is given by dx by dt. Now this is the first order of derivative, right? Velocity in this case is the first order of derivative of its displacement with time, displacement x with time. Okay, and Akshay has said the total velocity, the speedometer of a car, instantaneous speed is example of instantaneous speed. Speedometer of your car actually gives the, actually this gives you the instantaneous speed at all point in your journey. Okay, now right, so let's carry on from here. This far we have done, so let's begin. What is uniform motion? Okay, now if you have an object is said to be in uniform motion if it is covering equal distance in equal interval of time. Okay, however small these intervals may be, okay, in a fixed direction, right? If it is going in one single direction, when you say whatever it is, let's say it's going in one single direction and it's covering equal distance in equal intervals of time. Let's say it's covering 5 meters, right, in 5 seconds or in 7 seconds. 5 meters in 7 seconds, right? Now the object is covering equal distances in equal intervals of time. However small these intervals may be in, and it's going in one single direction, there is no change in direction also. Okay, that's basically your uniform motion. Now what will be your non-uniform motion? Now if an object is said to be in non-uniform motion, if its velocity changes with time. Okay, since we are talking about here is about velocity, and velocity is a vector quantity, there are two things that it can change here. Either the speed of an object, right? Either the speed of the object, either the speed of the object, right? There is a gap over here, or either the speed of the object, or right, its or its direction of motion, or both can change, right? That's basically your non-uniform motion. What for example, what would be an example, a perfect example of a non-uniform motion? Okay, let's say the bus is at a bus stop, right? Now it's at rest. As soon as it moves from the bus stop, right, its velocity, what happens to its velocity in this case? It will increase, velocity increases, right? Now and after some times, let's say it's going with a constant velocity. Okay, then what happens? It will slowly slow down and another bus stop comes, so it comes to a stop. What happens in this case? In between, let's say it reached a constant state, and in this gap what is happening? Velocity is decreasing. So if you see from the start to the stop, okay, the object is traveling with different velocities. The velocity is changing with time. Okay, not just the velocity, the direction also can change. Now this is an example of a non-uniform motion. Okay, now that we learned what is uniform and non-uniform motion, let's do a kinematic equation. Okay, formula for uniform motion. This is the formula for uniform motion. All right, now we're going to consider an object that is, okay, somewhere at the there's somewhere at over here O, and it's moving with uniform velocity, right? Uniform acceleration, so it's moving with kinematic equation for uniform motion, so it's moving with uniform velocity, and let's say this uniform velocity is v. Okay, so from here, and it's going in one particular direction. Let's say it's going around the positive x-axis. Let's say it's going in the positive direction. Okay, it's going in one direction, positive direction, easy for calculation, right? Now, let's say it is occupying from this point. Let's say after some time it came to this point over here, right? Let's say this point is somewhere around, at this point, let's say your time is equal to 0, t is 0, okay? Or time is basically at this time, the time that you're taking is 0. Okay, at time 0, it has reached the position of x0. Okay, after some time, at time t, this has reached its position of x. After some time, it has reached t dash at x dash. Okay, now if you want to calculate the velocity of the object, okay, now we want the velocity of the object. Okay, velocity of the object, we want to find the velocity of the object, but we want to find the velocity of the object only in this time interval from 0 to t. What is the velocity of the object? Okay, now this particular velocity would be given by what? Right, from 0 to t, right? This velocity will be given by, velocity v will be what? Velocity is given as displacement by time, right? What is the displacement over here? Displacement is, if you take the entire path, right, in the x-axis you have x0, x dash, right? That is the displacement, right? So this could be taken as an example of you starting, going to a market, from market you're going straight towards let's say a mall and back home, right? So you can take it as you're traveling a distance but making pit stops, but in this case you're taking only for the displacement will be from, velocity will be from here to here, right? Shortest distance traveled from point A to point B. What is the distance? What is the displacement? Okay, now what is the displacement over here? Displacement over here will be from x0 to x, right? So it will be x minus x0. Displacement in this case will be x minus x0. What will be the time then? What will be the change in time? Time started from 0 to time t, right? Time taken from 0 to time t. So this will be t minus 0. So that's your displacement. Okay. So from here we have v is equal to x minus x0 divided by t. So v into t will be equal to x minus x0. Right. So from here, if we want to write, this will be x will be equal to x0 plus v into t. Okay, now this particular equation, right, it basically gives you, this gives, right, this gives the position of the particle, right? We took a particle, right? We can say position of a particle or position of not or object, right? Position of a particle, okay, at instant t. Instant t, it has traveled from 0 to t. What is the position of the particle? Okay, now similarly we can do the same thing as we did now. We can do this now. Let's see what will be the velocity of the object when it travels from x to x dash. What will be the velocity of the object when it travels between this distance from x to x dash? Okay, I'm just going to do this bit in the next page. Alright, what is the velocity v when it travels from this position x to x dash. X dash, then that will be, velocity will be final minus initial, right? Velocity will be final displacement. This is basically x dash, right? Minus initial position. Final position, displacement is final minus initial position. Final position is this, initial position. In this case, we are transferring from x to x dash, right? So it will be x dash minus x by, right? By what is the final time? T dash, right? Initially it was t, right? From here you will get t dash minus t. right? Now here we can write this as v dash t dash minus t will be equal to x dash minus x. From here, if I write what will be my x dash, if I want my displacement, this will be x, right? X plus v into t dash, final time minus initial time, right? That will give me the time taken. Now, this equation basically gives the position of an object at instant t dash, okay? But this is giving the position of an object at instant t dash, but with respect to the position x at time t. Okay, now from equation 1, right, if you take this, look at this, this is position of an object, right, at a time t dash, right? What is the position of the object at time t dash? But it is giving it with respect to the first initial position at what time it was in. Okay, now if you look at the first equation, x minus x is equal to x dash minus x dash plus v x dash plus vt. Okay, let's take this equation. Okay, let's take x is equal to x naught plus vt. Now x minus x naught is basically v into t. Okay, now what is this x minus x naught? Right, this is x minus x naught is basically the object which was here got displaced over here, right? So this is the final position, this is the initial position. So that's how we got x minus x dash. So this is basically displacement. X minus x dash, this is basically displacement, right? This is basically displacement. This gives you displacement when? Displacement in what? Displacement in time interval from 0 to t. So it gives you the displacement, right? This position gives you the displacement. X minus x0 talks about displacement, but in what? In time t. In time t, how much? What is the displacement? Okay, so we can say this is displacement in time t. Okay, now let's say this quantity x minus x naught, let's say displacement in time c, let's take that as yes. Displacement to be yes. Okay, so from there what will happen to this equation over here? It will become s is equal to v into t. Okay, now this equation you can use to determine what? The distance traveled by an object in uniform motion. If you want to find what is the distance traveled, okay, distance traveled by an object in uniform motion, you can use this equation to find. All right. Okay, so with this note, let's actually see what is acceleration. Okay, now acceleration is nothing but the rate of change of velocity of an object. Okay, now if there is a change in velocity, change in displacement, right? If there is a change in displacement with time, that's velocity. Now rate of change of velocity of an object with time is called as acceleration. Acceleration basically just tells you how fast an object, okay, changes with time, how fast the velocity of an object changes with time. So that's what acceleration tells you about. Okay, now so acceleration, you can give acceleration as acceleration is nothing but change in velocity by time. Okay, what quantity is acceleration? Is it a scalar? Is it a vector? Acceleration, this is basically a scalar quantity. Acceleration will basically be a vector quantity, right? And what is the direction of this vector quantity? That will basically depend on the direction of the velocity. Whatever is the direction of the velocity, the direction of acceleration will be that. Okay, now what is the SI unit? What the SI unit of acceleration? What will be the SI unit of acceleration? This will be, what will be the SI unit? Okay, SI unit will be this velocity is given by meter second inverse 1. Then time, actually this becomes inverse 1 again. So acceleration is basically given as meter inverse 1 per second, right? So when the second comes up, it will become second inverse 2, right? So this acceleration is given by meter per second square, right? Now what will be the dimensional formula, right? Mass is 0, meter, so length is 1, and the seconds over here is t inverse, t to the power of minus 2, right? That is the dimensional formula for acceleration. Just like how you have different types of speed and velocity, we also have different types of acceleration. So acceleration can be uniform acceleration, right? Then it can be your variable acceleration, then it can be your average acceleration, and it can be your instantaneous acceleration as well. Okay, now what is uniform acceleration? Very simple. The acceleration of an object is said to be uniform when, if the velocity changes by equal amount in equal interval of time, however small that changes. Okay, for example, if the velocity of a particular object, okay, let's say a car is going, let's say the velocity in which it is going, right? Let's say for time 1 minute, let's say the acceleration velocity of the car is 15 meter per second. For the next 1 minute, the velocity of the car is 15 meter per second. For the next 1 minute, the velocity of the car is 15 meter per second. Now if this happens, then what we say, then the acceleration we talk about is basically uniform acceleration, right? If the acceleration of an object is said to be uniform, if its velocity changes by equal amount in equal interval of time, however small this time interval can be. Okay, now second type is what is variable acceleration. Now the acceleration of an object is said to be variable acceleration if its velocity changes by unequal amount in equal interval of time. Okay, for example, let's say the car is going, let's say for the first 1 minute, the car goes in 15 meters per second. For the second 1 minute, let's say the car goes in 20 meters per second. The third 1 minute, let's say the car is slowing down and it's going at 5 meters per second. The velocity is actually changing, right? But for the equal amount time interval we have taken, the velocity is actually changing. This is basically given by your variable acceleration. Now, from variable acceleration, for an object that is moving in a variable acceleration, right, that has a variable velocity, okay, then for an object that is moving with a variable velocity, that is the displacement it's covering with time, for equal intervals it's covering unequal distance, displacements, okay, the length it's covering, the displacement it's having is unequal with time, or there is a change in direction. Both can also happen. Okay, for an object moving with variable velocity, the average acceleration is defined as the ratio of total change in the velocity of the object to the total time interval taken. Okay, now let's say the velocity, let's say the object has two velocities, right? Initially, let's say the velocity of the object was v1, final velocity was v2, okay, and this was initial. Okay, and let's say final. Or there are just two different velocity of the objects. Okay, the object just has two different velocities. Okay, v1 and v2. Okay, this velocity it had was in the time t1. This velocity was had in the time t2. Okay, now average velocity will be what? My average velocity will be right, final velocity minus initial velocity by final time taken minus the initial time taken. Okay, so this you can give it as delta V, change in the ratio of total change in the velocity of an object to total time interval taken, that is delta V by delta T. This is basically your average acceleration. Okay, next comes your instantaneous acceleration. Okay, the acceleration, right now the acceleration of an object at a given instant of time or at a given point of its motion, it's called as instantaneous acceleration. Okay, now in this case, let's say it is equal to, we can take it in terms of limits. All right, acceleration, we can take this as the limiting value of the average acceleration of an object in a small interval of time around that particular instant. Let's say this time going towards 0, right? As the time interval is actually approaching towards 0, this will be dv by dt, right? Now this will be nothing but dv by dt. Now v is nothing but dx, that is the change in displacement by time, right? Rate of change of displacement with time. From here we can get a is nothing but d by dt of what is v? Dx by dt, right? So here, from here we can say a is nothing but d square x by dt square, right? From here we can say acceleration is the first order derivative for velocity. It's the first order derivative for velocity. For d square x by dt square, this will be its second order, okay, derivative of position with respect to time t. Second order derivative, acceleration becomes your, and second order derivative of position, second order derivation of position, first order derivative of velocity, but second order derivation of position with respect to time. All right, that's your actual instantaneous acceleration. It's same as the concepts we have done before. Now, other than this, we also have positive acceleration. So if an object, the velocity of the object increases with time, its acceleration is positive acceleration. Can you think of an example of positive acceleration? Similarly, there we also have negative acceleration. So this is if the velocity of an object increases with time, right, decreases with time, then its acceleration is negative. What is an example of positive acceleration? What will be an example of positive acceleration? Right, very simple. Okay, when a bus just leaves a bus stop, what happens? For initially, the distance covered was when it was at rest, right? It was initially at rest. It's in the bus stop, it's at rest. Now, as time passes by, what happens? The bus, which was basically in the bus stop, goes over here, right? Somewhere over here is the distance traveled. So, it has covered a distance with time. It's covered a distance d with time. So, what happened? As the bus is moving, the bus leaves the bus stop and start going. Now, after some time, you'll find the bus somewhere over here. Now, the distance has further increased and so is the time taken. So, what happens? The velocity of the object increases with time, right? Then we say the acceleration is basically positive. Okay. Now, what will be negative acceleration? Very simple. The bus which is moving comes to the bus stop. So, what happens? So, bus will slow down. So, it was covering initially whatever distance. Let's say initially it was covering, the velocity it was going was 5 meters per second, right? Now, what happens? It becomes 3 meters per second, 2 meters per second. The distance it is covering actually becomes length. The displacement also becomes less, and finally it comes to the rest, right? The velocity becomes 0, right? So, if the velocity of an object decreases with time, okay, then you say it's negative acceleration. The perfect example would be your bus, when you slow down, when a bus slows down on approaching a bus stop, right? Its acceleration is basically negative. So, this is also, negative acceleration is also called as retardation, okay, or deceleration. Okay, this is with cases of acceleration. All right. Now, before we go ahead, right, with the kinematic equations of motion, right, this is for uniformly accelerated. What will happen for uniformly accelerated motion? What is the kinematic equation? Before we go ahead with that, okay, let's do a very quick, let's look at two special cases. Okay, let's look at two special cases. This is, what is the average speed in different situations? Let's look at average speeds in different situations. Average speed in different situations. Okay, first situation we are going to look at is when, okay, when a body or an object covering different distances with different speed. Okay, Now let's say an object covers a distance, okay. Let's say the distance that it covers is somewhere around, let's say first it covers S1, the distance covered is S1, S2, S3, okay. Those are the different distance it covers, okay. And what is the speed in which it is going? So for, let's say this first one is V1, V2 and V3, okay. At all points the distance covered, hence the speed is different, okay. Now from here, what is average speed? Average speed is given by total distance traveled by time, total time taken, okay. Now what is the total time travel over here? Let's say that is S, total time taken, T. But what is the S over here? Total time travel, total change in displacement. So the total distance traveled, the distance traveled will be, first it traveled a distance of S1, let that be like somewhere around 500 meters, then maybe S2, right? Let's say for the next few minutes the distance covered was basically around 1 meter, and then it covered 1 kilometer, let that be S3, right? Now likewise the distance covered with time is different, right? So the distance covered is different. So this is S1, S2, S3 and so on, right? It covered is different. For every time taken, right? Time taken is also different, right? For S1, let's say time taken is just few seconds, a few meters, right? Let's say it's covering 500 meters in 2 minutes, and then say let's say around 10 meters in around 5 seconds, okay. Then 1 kilometer around 20 minutes, okay. Then this will be T3. So the distance with, as the distance covered with time also changes, right? This is S1, S2, S3 by T1, T2, T3 and so on, right? From here, if you look at the average, right, this will be S1 plus S2 plus S3 plus and so on. How can you write time in this case? We know velocity, right? Velocity is given by distance by time. From here we can write time is given by distance by velocity, okay. So likewise for this equation over here, that is T1, T2, T3, let's use this logic, okay. For time T1, let's say time T1, it covers the distance, okay. Time can be given as distance by, so velocity by distance by velocity. Using the same logic, T1 can be written as S1 by V1 plus S2 by V2 plus S3 by V3 plus and so on, okay. Now in this case we will look at a special case, okay. Now in case, okay, the distance traveled becomes equal. In case we are assuming, in this case the first assumption we are doing is the distance traveled becomes equal, that is S1 is equal to S2 is equal to S3. Let's say all of this becomes S, or let's say let's just take two distances, S1 and S2, right? The distance it is covering is same, but it's covering with different speed. Let's say the object is covering, the distance it is covering from S1 to S2, right? Distance it's covering is same, but speed is different, okay. Then average will be what? Velocity average will be what? This will be S1 plus S2 divided by S1 by V1 plus S2 by V2, right? Here we said S1 and S2 is equal to S, so this will be 2S by, over here what can you do? You can actually take S commonly outside, because S1 and S2 is equal to S, so you can take S commonly outside, or you can actually write this as, S by V1 plus S by V2. So from here what can we do? We can actually take this S commonly outside, right? So here, now from here we can write this as V average as 2 divided by, right, V2 plus V1 by V1 V2, right? From here V average will be 2 V1 V2 divided by V1 plus V2. So the average speed, if you see, is actually shown as a harmonic mean of the individual speed. speeds. Okay, likewise, you can actually show that your average speed, okay, likewise you can take your average speed. Okay, this time what you're going to do is you're going to say that the distance covered, right, instead of say v1, right, like we have s1 plus s2 plus s3 distance covered with time, t1 plus t2 plus t3, different time covered, right? Now what we are going to do is, we know v is equal to s by t, right? From here, what is s is equal to v into t. So we're going to substitute for the same. So what will be s over here? v1 into t1 plus v2 plus t2 plus v2 into t2, v3 into t3, and so on by t1 plus t2 plus t3. t1 plus t2 plus t3, all of it together will become your total time. v1 plus t1, v2 plus v2, this will give you the total distance, right? Total path length or the total distance covered, right? Now from here, let's say the time, okay, let's say time becomes equal t1 is equal to t2, this is equal to t3, and so on up to tn. All of this, the total time becomes t. Okay, let's say total time becomes t. This is a special case, right? So what will happen to the average speed now, right? Now average speed, now we have v1 plus v2 plus v3 and so on, right, up to vn. Now into t1, t2, t3, all of it becomes t, right? So I can write commonly t commonly outside, right, by here t1 plus t2 plus t, all of it becomes t, right, up to tnth term, right, also becomes t. So this here it will become n times t, right? So here it becomes n times t. So from here we can see average velocity is v1 plus v2 plus v3 and so on up to vn divided by n. Okay, so average velocity in this case is given as what? Arithmetic mean of individual speed. Okay, so we saw two cases. So this is the case when a body, okay, when a body moving with different speeds in different time intervals. Okay, first case we took a body covering different distances with different speeds. In that case we found average speed was basically the harmonic mean of the individual speed. Now next case we did body moving with different speed in different time intervals. Now we got the average velocity or the average speed is the arithmetic mean of individual speed. Okay, the two special cases that we have seen today. With that note, we are coming towards the end of today's class. Once again, there is an upcoming batch. It is going to start only from tomorrow. So this batch, the mode of delivery will be in English. So the target of this course is going to be your midterm syllabus coverage. Alright. So we are going to be doing the units from the first 5 units, right? Whatever is your first 5 units, that is what we will be covering. Alright. Now the term 1 syllabus will be covered here. For physics, we will meet every Tuesday, Wednesday, Thursday, Saturday between 5:15 to 6:15 p.m. Similarly, for math, Jyoti ma'am will take, physics I will take, chemistry Manisha ma'am will take, and biology Lakshay sir will be taking. Now for class 11, if in case you're taking the class 11 subscription, the class 12 subscription, 1 year of class 12 subscription is absolutely free. You just have to pay for 1 year and you're getting the subscription for 2 years, worth for 2 years. Okay. Now, if you take, whenever you take a plus subscription, it will be for an entire course. It will be for math, physics, chemistry and biology as well. Okay. Now, you can use my code. Whatever price is given per month, if you're taking for 1 year, the price actually reduces. Now, if you take 1 year subscription, 2 year subscription is absolutely free. On top of it, if you're using my code MTIS10, you will basically get a 10% discount on the same. Okay. Now, minimum there will be 10 classes in a month. In a month, minimum there will be 10 classes for math, 10 classes for physics, 10 classes for chemistry and 10 classes for biology. Okay, each class duration is 1 hour. Every 4th class will be a doubt clearing session, right? If you have any further queries or questions regarding the same, you can contact me through. You can actually drop a text. You can actually ask me in the comment box. right? Or you can contact, there will be a number given in the description box, you can actually contact there as well. Okay, this is the minimum number of classes covered in a month, right? Apart from this, they would be, you will also have live test series, right? Every other week you'll have live test series. There is one coming this weekend as well, and after the test series you will have an analysis session, right? So where you can know whether, if in case you got any questions wrong, you can know what is the right way to solve the questions, and in case if you want to know what are the shortcuts to solve the questions, you can know the same as well. All right, so with this note, I'm coming towards the end of the session, and we have a community app. So usually I'll ask some pool type questions in my community, right? You can actually check out the link to my community is given here. You can check out the same, and there'll be some questions based on the unit. These are just MCQs, and so you can just try attempting them. Those questions asked as of now based on your unit 1. Okay, you can try just attempting it, and you don't have to miss any update from your favorite educators. You can also share your feedback directly with your educator via pool. Okay, and in case in any of the videos, if you're finding any inappropriate content, you can actually claim, if you're reporting the same, you can claim your prize. And please like and share, right? If you like the class videos, like and share the class videos among your friends, and also click on the bell icon to subscribe, and also subscribe to the channel. Click on the bell icon so the next time the classes are happening, right, you will get a notification as well. So with this note, I'm coming towards the end of the session. And I've also, in the description box, there's a link for the classes happening in the Unacademy platform. So you can go there and just click on notify button. So when the classes goes live on the platform, you can join there as well. Okay. So if you have any questions, I'm here to clarify. Otherwise, I'll be ending the class now. And thank you guys.